Hi guys, so today I'm going to be talking about assignment 20, which is 11.5 alternating series, in which for the first question it's asking us to test this series here for convergence or divergence. And just to recap on the notes, an alternating series is a series whose terms are alternately positive and negative. And so if we look down here for the alternating series test, the series has to be decreasing and the limit has to be approaching zero in order for it to be convergent. And so for this first one here, we're going to take this here and actually take it, so it's f of x equals x squared over x cubed plus 1, in which we're going to take the derivative of this function. So we're going to get f prime of x equals low d high minus high d low all over low squared. And if you simplify it through, you're eventually going to end up with x equals negative x times x to the third minus 2 over x to the third plus 1 squared, in which this is in fact decreasing. So let's check on step 1, and then for step 2, now we're going to be taking the limit of this, in which it's already set up, so we can actually just take the limit as n approaches infinity of n squared over n cubed plus 1, in which will unfortunately end up with infinity over infinity, and we don't want that, so we have to apply L'Hopital's rule. And when we do that, we'll get limit as n approaches infinity to n over 3n squared, and once again we end up with infinity over infinity, and we don't want that, so we're going to apply L'Hopital's rule again. To finally get the limit as n approaches infinity 2 over 6n, and we'll get 2 over infinity this time, which is 0. So because it is equal to 0 and it is also decreasing by the alternating series test, the series of negative 1 to the n plus 1 times n squared over n cubed plus 1 is convergent. And for the second one here, it is asking true or false. The series here converges by the alternating series test. So once again, I'm actually going to rewrite this series here so it is set up in this format instead. Negative 1 to the 2n times 1 over n squared. And we're going to take this here and rewrite that so it is f of x equals 1 over x squared, in which if we take the derivative, we are going to get negative 2 over n cubed. And we can see that this is in fact decreasing. Okay, and so for the second part, we're going to take the limit as n approaches infinity of 1 over n squared to get 1 over infinity, and that's going to be 0. So because this series is decreasing and is also 0, the limit is approaching 0, by the alternating series test, the series -1 to the 2n over n squared is convergent. So the statement is true.